Hello students, here we are going to study about multiplication of unsigned number. Unsigned multiplication is nothing but both the numbers are positive numbers. We already know how these two numbers are getting multiplied and get the final product result. These are all the partial product. This is the circuit we are going to use for unsigned multiplication. First we identify what are the components present in this circuit. First one is multiplier circuit. It is a 32-bit register. And second one is the multiplicand register. And third one is the product register. This product as well as multiplicand both are the double the size of the multiplier. Because during this process we are going to add this multiplicand and product by this arithmetic and logic unit. So these two register size should be same. If it is a 4-bit number, then we can use 8-bit multiplicand as well as 8-bit product. So these two register content can be added with arithmetic and logic unit. Then appropriate control signals can be generated by this control mechanism. Then first you set the initial values for these registers. That can be written in this tabular format. So in this example, I am going to multiply 2 into 3. 2 can be written in 4-bit format. 3 also written in 4-bit format. Your product is 8-bit number, so I can introduce necessary 0 in the left hand side of the multiplicand. So before starting the process, we should maintain multiplicand and product. That means multiplicand and product. Both the number are having same number of bits. Let's start this process. So you can use this algorithm to achieve this task. So first you test the rightmost digit of the multiplier. If it is 0, you can do this operation. If it is 1, you can add the multiplicand and product. The result is updated in the product. Then you can do these two steps. This process can be continued up to n number of times. That means the number of bits. If the number of bits 4 means you can repeat this operation 4 times. But in this circuit, this is the 32-bit number. So this process can be iterated up to 32 number of times. So first you write the initial condition in the tabular column. The first column is number of iteration. Initially it becomes 0. Multiplier can be written in the original value, that is 3. And this is the multiplicand. So this is 0010. We can add the necessary 0 in the left hand side. And product is the double the size of the multiplier. Initially it is 0. First you check the rightmost bit of the multiplier. Here the rightmost bit is 1. So we can do this operation. So this is nothing but we can add the multiplicand as well as product and store the result in product. If you are adding these two numbers, we can get this result. So that can be updated here. So for this step, this value is updated. You can write the same value for the remaining columns. Then go to the next step. The next step is left shift of multiplicand and right shift of the multiplier. So these two steps can be executed in any order. So first I do this step. So if I do the multiplier right shift means, so this one is sent out. So this one can be written here. This 0 can be written here. This 0 can be written here. New 0 is introduced. So for this step, you are going to update this value only. You can write this value as it is. Then in the next step, you can do the left shift of the multiplicand. So this is the multiplicand. You can do the left shift. So 0 can be sent out. The remaining digits can be shifted in left. Then you can write these two values as it is in the previous step. Then you can compare the number of iteration. So this is the first iteration. So your number is 4-bit number. So this process can be iterated up to 4 times. So first time is over. So this process can be continued again. Now you can check the multiplier rightmost bit. So the multiplier rightmost bit is again 1. So we can do this process again. That is nothing but you are going to add these two numbers. So these two numbers can be written here. After adding you can get this value. So this value can be updated here. So you can write the remaining values as it is. So after this you can do these two steps. So first I right shift the multiplier. So multiplier right shift means this one can be sent out. So remaining values are 0. Then you can write the same value in the previous one. Then left shift of multiplicand. So this is the multiplicand. You can do the left shift. You can write the remaining values as it is. So the second step is over. Then you can repeat this process again. So again you check the multiplier rightmost bit. So multiplier rightmost bit is 0. So you just do the shifting operations only. So you just exclude this addition operation. So for this 0 we can do nothing. That means you can write these values as it is. Then right shift of the multiplier. Multiplier after right shifting you can get the same value. So you can write these values as it is. Then left shift of the multiplicand. You can do the left shift for the multiplicand. Write the remaining values as it is. So up to third step is over. You can repeat these steps again. Again you can check the rightmost bit of the multiplier. It is 0. That means you can do the shifting operations only. So after shifting you can get this value. Finally, you can check the product register content. So this value is nothing but 6. So 2 into 3 you can get 6. So for this process you should remember this algorithm as well as this circuit.